Welcome to a deep dive into the Hypertext Transfer Protocol, or HTTP. In this session, we will explore the request and response model, various methods, and status codes that form the backbone of web communication. Let's get started. Here is a basic diagram showing client-server architecture. The client, often a web browser, sends a request to the server. The server then processes the request and sends back a response. This simple exchange is the foundation of how we interact with the web. Let's examine the structure of an HTTP request. An HTTP request consists of four main components: the request line, headers, an empty line, and the body. The request line includes the method, such as GET or POST, the Uniform Resource Locator or URL, and the HTTP version being used. Headers are key value pairs that provide additional metadata about the request, such as the host and content type. An empty line separates the headers from the body. The body contains optional data, typically used with POST or PUT requests. This is where you might include data like form information or a JSON payload. Here's an example of an HTTP request. This is a POST request to API users using HTTP version 1.1. It includes headers such as host, content type, authorization, and content length. The body contains a JSON object with name and email fields. Now, let's turn our attention to the structure of an HTTP response. An HTTP response also has four main components: the status line, headers, an empty line, and the body. The status line includes the HTTP version, a status code indicating the outcome of the request, and a status text providing a brief description of the status code. Headers, as in the request, are key value pairs offering metadata about the response. An empty line separates the headers from the body. The body contains the actual response data, which could be HTML, JSON, or other formats. Here's an example of an HTTP response. The status line indicates HTTP version 1.1 with status code 200 OK. The header includes date, server type, content type, and content length. The body contains a JSON object with fields like ID, name, email, and status. Next, let's discuss common HTTP methods. HTTP methods indicate the desired action to be performed on the identified resource. Here are some of the most frequently used methods. The GET method retrieves data from the server and should not modify any resources. For example, get/API/user/123 would fetch user data with the ID 123. The POST method creates a new resource on the server and may trigger side effects. For example, post/API/users could create a new user. The PUT method updates or replaces an existing resource completely. The delete method removes a specific resource from the server. For example, delete/API/users/123 would remove user with ID 123. The patch method partially updates an existing resource. For example, patch/API/users/123 could update only the email address of user 123. The head method is similar to GET but retrieves only the headers without the body. It's used to check resource metadata. Now let's delve into HTTP status codes. HTTP status codes are three-digit codes that the server returns in response to a request. These codes indicate whether the request was successful, encountered an error, or requires further action. Status codes are grouped into 5 categories: informational, success, redirection, client error, and server error. Informational codes range from 100 to 199 and indicate that the request was received and is being processed. Success codes range from 200 to 299 and indicate that the request was successful. Some common success codes include 200 OK, 201 created, 202 accepted, and 204 no content. Redirection codes range from 300 to 399 and indicate that the client must take additional action to complete the request. Common redirection codes include 301 moved permanently, 302 found, 304 not modified, and 307 temporary redirect. Client error codes range from 400 to 499 and indicate that the client made an error in the request. Common client error codes include 400 bad request, 401 unauthorized, 403 forbidden, 404 not found, 422 unprocessable entity, and 429 too many requests. Server error codes range from 500 to 599 and indicate that the server encountered an error while processing the request. Common server error codes include 500 internal server error, 501 not implemented, 502 bad gateway, 503 service unavailable, and 504 gateway timeout. Let's discuss HTTP headers. HTTP headers are key value pairs that provide additional information about the request or response. They allow clients and servers to pass additional information with an HTTP request or response. Here are some common request headers. Accept specifies the content types the client can process. Authorization contains credentials for authenticating the client. User agent identifies the client application or browser. Content type indicates the media type of the request body. Cookie contains stored HTTP cookies. Here are some common response headers. Content type indicates the media type of the response body. Cache control provides directives for caching mechanisms. Set cookie sends cookies from the server to the client. Content length indicates the size of the response body in bytes. Access control allow origin indicates whether a resource can be shared across domains. Now let's discuss HTTP content types. HTTP content types, also known as MIME types, indicate the format of the data being transmitted in a request or response. Here are some commonly used content types. JavaScript Object Notation, or JSON, uses the MIME type application/JSON. It is a lightweight data interchange format. XML, or Extensible Markup Language, uses the MIME type application/XML, and it is a structured data format. HTML, or Hypertext Markup Language, uses the MIME type text/HTML, and it defines web page structure. Form data uses the MIME type application XWWW form URL encoded. It represents form data sent in the URL encoded format. Let's explore HTTP authentication methods. HTTP authentication methods are used to verify the identity of a client before granting access to protected resources. Here are some common authentication methods. Basic authentication sends a username and password encoded in base64 format. It is a simple method but not very secure without HTTPS. Bearer token uses tokens, often JSON Web Tokens or JWTs, for authentication and is commonly used with stateless APIs and microservices. OAuth 2.0 is an authorization framework that enables third-party applications to obtain limited access to a service. API key is a simple string that identifies the calling application and can be sent in headers, query parameters, or the body. Now let's discuss HTTP caching. HTTP caching is a technique used to store and reuse previously retrieved resources to reduce network traffic, decrease server load, and improve performance. Some benefits of HTTP caching are reduced server load, decreased bandwidth usage, improved page load times, and an overall better user experience. There are different types of caches available. A browser cache stores resources locally on the user's device for faster access on subsequent visits. A proxy cache are intermediate servers that store copies of resources to serve multiple clients. A content delivery network, or CDN, is a distributed network of servers that cache content closer to users. The cache control header allows you to specify various directives. MaxAge specifies the maximum time in seconds a resource can be cached. No cache requires validation with the origin server before using a cached copy. No store prevents caching of the resource entirely. Public or private controls whether the response can be cached by shared caches, which is public, or only by the browser, which is private. Lastly, let's explore the evolution of HTTP and some best practices. HTTP has evolved through several versions, each bringing improvements in performance, security, and functionality. HTTP version 1.0 was introduced in 1996 with one request per connection and basic functionality with headers and methods. HTTP version 1.1 was introduced in 1997 with persistent connections, chunk transfers, and additional caching mechanisms. HTTP version 2 was introduced in 2015 with multiplex connections, server push, header compression, and a binary protocol. HTTP version 3 was introduced in 2022 using the Quick Transport Protocol and improved performance over unreliable networks with reduced latency. Here are some HTTP best practices. Always use HTTPS to encrypt data in transit and protect user privacy. Implement caching, setting appropriate cache headers to improve performance and reduce server load. Follow representational state transfer or RESTful design, using appropriate HTTP methods for operations and following REST principles. Implement compression, enabling gzip or Brotli compression to reduce payload size and improve load times. Use security headers like Content Security Policy or CSP, HTTP Strict Transport Security or HSTS, and X content type options to protect against common web vulnerabilities. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.